Hello everyone, good evening. I hope all of you are fine. Good, very good evening everyone. Very good evening. I hope all of you are fine and learning well. My name is Vishvadeep and I am here today going to cover another half of components of computer. So why I am saying another half? Just because the first half of components of computer we have discussed already in previous class. So if you are new here, you have joined today only the first time, then you can watch previous two lectures. Yes, this is just the third lecture we are having today. So previous two lectures you can watch along with this so that you can understand every single thing till now whatever I taught to you. Fine. Okay. So whoever have reached here, whoever watching me live, just like the video. Okay. So that marks your attendance here that you are here. After that, subscribe the channel. If you haven't subscribed the channel, subscribe the channel, just because on this channel we are going to bring you more and more content about other courses also, other batches also, and some more things about computer science engineering. So all the people here, subscribe the channel so that you can get all the notifications from our side. Okay, so if you are here and you want us to continue more and more and more better content to be delivered to you guys, then you need to share the link to all of your friends in all of your social media and all the groups you have. So it's a very simple thing that you just copy the link from here, whatever the video you are watching right now, this link you share with all of your friends so that those people also can join us live here. Yes, that is very important, just because if all the people will learn here live, then definitely that particular thing will be having a more and more advantage. All the people who have joined just now, again I am repeating, like the video. Last time I have got so many queries from so many students that, sir, when this particular course will finish. As of now, this is just the third lecture, and when this particular course will be finished. See, this subject I can finish up to September mid, but there are some other course also going to be launched in August for computer science gate. Those also will be going on. Now students were asking another question, that, sir, till what time this entire subject or this entire syllabus of gate will be covered. See, the thing is, I am telling you, maybe first time or maybe I have told you the same thing in other channels, that the purpose of YouTube classes is to provide you, the purpose of the YouTube classes is to provide you the quality content. So there will not be any measurement of the less quality. The quality will be up to the mark, up to the gate syllabus mark. Of course, everything I am going to cover, my entire team is going to cover, but there is no any guarantee that when we can finish the subjects. Yes, there is no any guarantee, just because here we are to provide you the quality content. And if you are facing the problem that if you will be getting late for your preparation, if the courses will get late or something, then you need to come on Unacademy Plus, sir. Seriously, you need to come on Unacademy Plus. Why? Just because there we are running the batches, and those batches will be covered before November, up to November mid, or max to max November third week, not more than that. So you can have sufficient amount of time to revise every single thing. And we will have the revision batches also there, so that you can revise every single thing along with us. Yes, we will run as soon as the courses will finish, and at the end, whenever your other courses will be finishing, at that time we will launch another batch, which will be revision batch, crash course kind of a batch. And in that batch we are going to cover entire syllabus again for your revision purpose, so that tension from your end will be eliminated. But here on YouTube we will provide you quality content, definitely quality content, yes, definitely, but there is no any guarantee that when all the courses will finish here. Okay, fine. So till that time, if anybody joined here later on, like the video and share the link with all your groups and friends so that we can have maximum number of students live so that you can be benefited. Okay, this is my profile. If you are seeing me first time, my name is Vishvadeep and I have written GATE exam multiple times with All India rank 19 as the highest rank. Masters from IISc, another MTech from BITS Pilani in data science. Yes, the latest trend. Having good experience, these are the courses I am teaching. So this computer organization I am teaching here also, and I have started on Unacademy Plus also with full-fledged discussion. Okay, and other than that, I am going to teach data structure also. And once your gate exam is done, then I am going to take some sessions on coding interview problems also, so that you will be prepared for your coding high-end interviews in really good companies once you are done with your masters. Fine. If you are going to take subscription of Unacademy Plus, then you will have to use this code VDEEP10 to get the discount. Might possible you will be getting a call from Unacademy also at that time also. Just tell them that if they'll ask, they will be asking you that if you have some code, you can tell yes, this is the code VDEEP10. Okay, so if you will say that this particular code, after that you just immediately message me. Once you will message me personally, I'll be telling you how you can message me. You can message me on Facebook, you can message me on Instagram, you can message me on Telegram also. Once you will message me that you have taken the subscription using my code, then you will get my personal mentorship for your preparation. In that mentorship, I'll be helping you to get all the preparation, all the plannings and everything done. Plus, I'll be giving you more and more and more practice materials for your preparation. So if you are going to join Unacademy Plus, use this code, immediately message me, and then you will be getting my personal mentorship regarding the exam. Why I'm saying, just because I am not having only single rank, I have written gate exam multiple times with 682 rank in just my third year. This is my final year rank. After that 119 after my masters, then 442 rank, 440 rank in another year 2018, and there are certain more gate ranks I am having. So if you really need my mentorship, I can give you as soon as you take the subscription VDEEP10. You use the code, get the discount, and send me message so that I can give you a good mentorship. Fine. So these are the plus subscriptions. Specialties, live classes, doubt clearing sessions, weekly test, rank improvement batches, crash courses, as I already mentioned, and we will be conducting the classes in Hindi and English both. So how to take the subscription? You guys are very what should I say, smart, intelligent. Yes, you guys are intelligent to use the computer systems. Get the subscription button done and take the subscription. Look at this. If you are going to take the subscription, this one or this one, it is very less, very less. It's just 40 rupees per day if you are taking 24 months ka subscription, and if you are taking 12 month subscription, it's just 60 rupees, almost 60 rupees per day. That's it. And it's not too much if you are really thinking about your gate, and if you are really thinking about IISc Bangalore or IITs or good colleges for your masters. This is not a big amount, 22,500, that's it. But you will have to use this code VDEEP10. Remember this and use this code for the payment. You have payment option for EMI also, debit card, PMI also available along with HDFC card and the Bajaj Fin card. Okay, so you can join us on multiple channels along with this Facebook group, which is for mechanical, civil, and CSC people. So if you'll join there, then you'll be getting all the details or all the announcements and everything about the whatever we are going to launch next. Fine. Okay, so स्वागत करिए हमारा. This is another profile page. I already explained you about myself, so there is no any other extra thing required for you guys. So let's start learning. But before that, I want you to like this video if you haven't till now, and let's start the discussion whatever we left yesterday. So I just want to know if you were there in the last class. Can you tell me till what point I have already explained? Of course, I have explained you accumulator and all types of architectures. What types of architectures we have, I have already explained it. Then after that, did I explain program counter? Yes, I have explained the program counter also, and I have solved a question regarding the program counter. Right now, next thing we are going to learn today is instruction register. Fine. Okay, let's do it. व्हाट इज इंस्ट्रक्शन रजिस्टर? देखिए, नाम से ही समझ में आ रहा है. विद द हेल्प ऑफ नेम इटसेल्फ यू कैन गेट टू नो दैट व्हाट इज इंस्ट्रक्शन रजिस्टर. इट इज यूज्ड टू स्टोर व्हाट instruction, but which instruction and how many instruction? It will be definitely storing only one instruction, but which one? That one which CPU brings from memory for execution. If CPU brings an instruction from memory which you remember, if you know basics of this course, then you might know about a word called as instruction fetch. So when the instruction is fetched from memory within the CPU, where it is kept in the instruction register, where it is kept in the instruction register, right? Okay, fine. Okay, so instruction register is used to store current instruction which CPU is executing. So whichever CPU takes for execution, that instruction is stored in the instruction register. You remember this? Very simple definition. Let's go next. Next one is stack pointer. Next one is stack pointer. Stack pointer does what? Okay, let's see that what stack pointer does. You all know that. You all know that what stack pointer stores. Stack pointer stores a pointer or an address of the top of the stack. अब ये क्या बोला है? This is not too big thing. It's very simple thing. It's very simple thing. In the memory for the execution purpose. In the memory for the execution purpose, there should be a stack. There should be what? A stack. And you all know that stack works on which principle? Stack works on last in first out principle. Means whichever element is stored on the last, that we call as the top of the stack, and that should be pointed by your stack pointer. By your what? Stack pointer. So within the CPU you have a stack pointer, and that stack pointer holds the address of what? This particular top element, the last inserted element. So top is nothing but last inserted element. So whichever the last inserted element we have, its address is stored onto the stack pointer. And why we need it? Just because to access the stack. Right? All right. So stack pointer is what? It is used to store the address of the top element of the stack. Simple, very simple, right? Okay, that's good. If you are fine with this, let's go with the next one. Next one is what? Flag register. Let's go with the flag register. Okay, so let me take another page here, and flag register. This flag register is having another name also called as status register. We are going to learn lots of things from here. Okay, we are going to learn lots of things from this particular topic itself. I'm not going to tell you only this, that it stores the status. No, no, no. I'm going to give you more and more details. Just stick to this particular screen. Just keep watching. Stay tuned and just look at this. Okay, this is ALU. Till now, in the previous lecture, I have given you what? अब तक आपने देखा कि ये ALU लेता है दो input. Till now, you have seen in my own lectures, I have told you that ALU takes two inputs. Those two inputs are what? Input operands. And over those two input operands, ALU performs the operation and the result is stored in the accumulator. This much I have already explained you, but another information now I am going to add from the previous knowledge you had still now. Now, what happens on the input operands? If CPU performs operation, then CPU means, sorry, ALU, I should say, ALU performs operation, but ALU generates two types of output. ALU generates two types of outputs. What are those two types of outputs? The first output is the result, and the second output is the status of that result. अब ये क्या चीज है status of the result? Okay, let me first draw my diagram and after that I'll explain you that what is the status of what? Status of this ALU result. Okay, okay, fine. So this is the status register where the status is stored. This is my status register. In this status register or flag register, we have small single bit given for 111111 flag. So one flag you will be having for sign S, one flag you will be having for Z, and there are some other flags. I'm not going to tell you that this bit only will be for sign, or this bit only for the Z, or this bit will be for this one. This is my implementation detail. 8085 can have something different status register. 8086 type of microprocessor can have different. So I am not talking about a very specific CPU. I am talking about a general scenario. These are some basic things can be present in the status register. Okay, so what happens? What this S says? This S says that sign. This Z says that if it is 0. Now I'll explain you what happens. Suppose addition of two numbers happened in this ALU. Two inputs you have given, addition of those numbers performed and accumulator is having the result. Now what happens in this status register after this addition is performed? Addition is performed and then based on that, my ALU will think that this addition's result is 0 or not. If addition's result is 0, which means I'll have to set the Z flag as set. I'll have to set this 0 flag. Why? Just because it indicates whatever the result ALU has generated, it indicates what? Whatever the result CPU ALU generated, that result is 0 result. Right? So whatever the current operation performed in ALU, if its result is 0, then this this 0 flag will be set. So when it will be set? When it will be set to 1, then when, just because, or when the ALU's result is what? ALU's result is equal to what? Is result equals to 0. And 0 flag will be reset. When it will be reset? 0. When ALU result is equal to non-zero or not equals to 0. When ALU result is not equals to 0, at that time, this particular 0 flag will not be set, or means it will be reset. Similarly, this sign flag says what? Suppose some operation is performed here in ALU and that operation's result is positive or negative. So result of course will be stored in accumulator and its sign is stored here. Its particular status is stored here. So if sign bit is 0, which means what happens, the result is positive result which ALU generated for this current operation. And if sign is 1, which means what, the result is negative. You need to give me the answers. Yeah, you need to type down here so that I can think that you are, or I can know that you are learning, right? So what happens with those status, zarurat kya hai, what is the necessity to store these status of the ALU result? Okay, I'll tell you that later. First I'll write down the definition. I'll write down the definition here. Why flag register or status register is used? it stores it stores the status of ALU result. Status of ALU result. आपको खाली आंख खोल के ऐसे बैठ के और सुनना नहीं है यहाँ पे, है ना? आप खाली सुनने नहीं आए हो, समझने आए हो. Okay, you are here to learn the things, not to listen the things or not to hear the things. So if you are learning, then you need to inform me that yes, you are learning. Yes, okay, so you need to inform me that you are learning. Hence what you need to do is you need to keep chatting with me here. You need to keep sending me chats here so that I can understand you are learning, right? It is very very important. So it stores the status of ALU result. And why this status is used to store? Why? Just because to check the conditions. What? For what these are stored? To check the conditions. To check the conditions. Okay, so what happens? How to check the condition? Suppose I'm just taking a simple example. Suppose you want to check if A greater than B or not. If A greater than B or not, you are checking this condition. So what my CPU will do? What my CPU will check it? CPU will perform A minus B in ALU. CPU will check what? CPU will check A minus B in ALU, and what? And status of this result will be checked. If status of the result is positive, which means what? Which means A is greater than B. Yes. So for condition check, what ALU will do? ALU will perform A minus B, and its status is stored here. If the status is positive, which means condition true. Which means what? Condition is true. So such kind of all the conditions which you write, all those conditions are checked based on the status registers, right? So remember that all those condition check, whichever you write in the higher programming language, higher level language, all those condition check are based on this status register content. Right? Okay, fine. So if you are fine with this flag register content, then there is a word called as program status word. Program status word. And it is in short known as PSW. You know, in some of the CPU, in some microprocessor designs or in some CPUs, what happened, this PSW is itself only the status register. The status register itself is known as PSW in some microprocessor, in some CPU design. Now some scientists are always saying different things. कुछ साइंटिस्ट होते हैं ही ऐसे हैं, हमको नहीं, हमको जमाने के साथ नहीं चलना. We are going into different direction. So in some scientist implementation, in some kind of CPUs, PSW has been taken as combination of two registers, accumulator plus status register. So if somewhere you read this also, that is also correct. Somewhere you read this, that is also correct. In different CPUs, the implementation of PSW is different. Don't worry about it. Okay. Don't worry about it. Don't worry about it. No problem at all. Okay. So if both are given program status word, something somewhere it is known as status register, somewhere it is known as accumulator plus status register. Okay. Fine. Next one is address register, and after that you are going to have data register. These, first of all, I'll be writing the definition and I will explain these two together. Okay. So let's start with the first one. Another one is address register. First among those, address register. What is address register? Right. So I am writing a definition, simple definition. It is used to send address to memory. Address to memory. And what is data register? I'll write the definition of data register also here. Data register is used for, it is used to send data to memory. This happens when you have the memory write operation, right? And to receive data from memory. In bracket, I can write memory read operation. Now I'll explain you. First I have given you the definition. आपको ज़्यादा हवा लगेगी नहीं. Okay, you will not understand much about it, but let me clarify every single thing with some more explanation about memory access and how these two registers are used for the memory access. I'll tell you every single thing now. Just concentrate on this particular thing which I am going to explain you here. It's very simple concept, but you remember that this I am talking about a very basic CPU design. Yes, we are going to learn only a basic CPU design which can be different in some specific CPUs, some complex CPUs and so on. Okay, so let's say this is suppose your CPU and here we have a memory. Of course, it is not your memory, just because your memory is not as large as it looks. This one बहुत छोटी है, आपको याद ही कहाँ रहता है कुछ. So this is the memory and this is your CPU. You know what happens if we want that memory should be accessible. If you talk about the main memory, then you are having 4 GB content, 4 gigabytes of content. Nowadays 4 GB ka RAM you use, right? So what happens while designing time, this main memory is designed like this, that it has such kind of small cells. What it has? Such kind of small cells. What we call this particular smallest part is as a cell. What we call it as cell. Why we call it as cell? Just because this is the smallest part of memory which can be uniquely accessible. Now if I am talking about accessible, which means I am talking about if a memory cell is accessible, then we should provide some kind of numbering to those cells. Yes, we provide some kind of numbering to those cells so that each cell has a unique number. With that number we can access that specific cell content. Okay, so this particular cell number starts with 0, then 1, then 2, then 3 and 4 and so on. And here these cell numbers are itself known as what we call these as memory addresses. And why we assign these cell numbers or addresses? Just because we can access each and every cell uniquely. Now, suppose CPU is having some kind of requirement that CPU wants to access a specific cell number 4. How CPU accesses cell number 4? CPU will have to send this cell number. Eventually it is nothing but address. It is nothing but address. So CPU sends address to memory that I want to access cell number 4 content, or I want to access the memory on the address 4. How CPU sends address to memory? Just in the previous class only, I have told you, in the previous class only I have told you how CPU sends address to memory using the address bus, right? So using this address bus, CPU sends an address to memory that on this specific address I want to access the memory. Now I guess you all are so much of intelligent, so much smart, and so much of aware of memory operations. So basically two types of operations can happen in the memory. Either memory read can happen or memory write can happen. Now if CPU has sent this address to memory, address number 4, assume that, then on that address, which operation is to be performed by memory? So memory will be confused that should I perform read operation on this address or write operation on this address. So for that there are two control signals. There are two control signals. These control signals will be the part of control bus. Okay, so will be the part of control bus definitely, and these two signals are what? A read signal for memory and a write signal for memory. So whichever operation CPU wants to perform, on the memory, CPU will do what? CPU will initiate, or CPU will enable. Oh, I have to take the line from here. CPU will enable among these two operations. One operation will be enabled, that whichever operation CPU wants to perform, either read or write. So suppose what happens if CPU wants to perform read operation on this address 4. So CPU will send the address to memory on address number 4, and among these two one signal will be enabled. Either read will be enabled or write will be enabled. If read is enabled, which means memory will understand I will have to accept this address. On that address I will have to read the content on this address 4. Read the content on address 4. Right. Suppose I'm just assuming that it is the memory read operation. I'll give you all the statements that what happens in the read, what is the sequence followed, and everything. I'll give you the statement. Don't worry, just learn here first. Just learn here. Don't worry about the notes. So suppose CPU sends the address through address bus 4. Now at address 4, what should be performed? Suppose CPU generates the enabled read signal. So this is enabled right now, this is disabled. Okay, so enabled read means memory understands on this address number 4 I'll have to go and I'll have to read the content from here. अब पढ़ने के बाद करेगा क्या? रीड कर लिया, उसके बाद करेगा क्या? What memory will do after reading this content? After reading this content, memory will have to send it to CPU. कि I have read the content, now I am sending it for you. So after reading the content, memory will send that content to CPU. Memory will send that content to CPU using a bus called as data bus. What it is called as? Data bus. So in the memory read, what happens? CPU sends address, then CPU sends read signal. Memory reads the content and sends that content to CPU by this data bus. Now let's talk about memory write. So in the memory, something is to be write, some data is to be write. So what CPU will do? CPU will send some address. Let's assume any address, 1, 2, 3, 4, 5, 50, 100. So many addresses are there. So CPU sends address, assuming that this address. On this address, if write should be happening, on this address, let's say write should be happening, then what data to write? Memory will say na, memory will ask that what data to write. So CPU will send the address and CPU will send the data also to memory, so that through this data bus, data also CPU will send to memory, so that this data on this specific address can be written here. Right now, how memory will understand that I'll have to perform write operation? This write signal this time will be enabled and this will be disabled. Right? So any memory operation happens, this CPU will send the address through this address bus. Yes. But if suppose it is a memory read operation, from where to where data is going? In the memory read operation, you need to type down the answer here in the comment box. I'll be reading about it, that if CPU memory is performing read operation, from where to where data is going. The data will go from memory to CPU through this data bus. If memory write operation is there, then if memory write operation is there, then what happens? If memory write operation is there, then what happens? In the memory write operation, data will go from CPU to memory. So this data bus will carry the data in both the direction. When there is a memory read operation, memory will send the data bus will carry the data towards CPU. When there is a memory write operation, CPU will send the data towards the memory. Right? So this data bus will be used for both the side transfer of data. Right? Now, let's come to this particular point. Where are the address register and data register we were talking about? Where are those two things? So now listen, when a basic system design is there, then this particular address bus is starting from address register. So when a basic CPU design is there, the address bus is the originating point of the address bus. So any address CPU wants to send to memory for read or write, any address CPU wants to send to memory, that address first comes to address register, and from there only it can be sent through this address bus to memory. Remember this. Similarly, what happens? This data bus is not ending to the CPU like this a dabba. Okay, this data bus goes towards the CPU and it ends up to a register called as data register. So anytime data is going towards memory or coming from the memory, this data register is used. Now, whatever you have learned till now, I am asking you again. In the memory read, data is coming. In the memory read, data is coming from memory to CPU. Hence, data register is receiving the content. Right, receiving the content from this data bus. Yes, so you can see that data register is used to receive the data from memory, and which one? Memory read operation. Okay, and then this particular data register is used to send the data to memory when the memory write operation. So these two definitions I have written for both operation, for both the work. This particular data register can be used to send the data or to receive the data. I have written the definition also, or operation also, which write or read operation will be used for what, and then address register always sending the address to memory. Fine. Now what happens? Okay, you might have something from yesterday, that when the wait signal and the ready signal will be used. So wait signal and ready signal will be used to inform to CPU that memory is right now working, or if it is busy, or if it is free to work. Memory can be either busy or can be free. So how CPU will get to know about that? CPU will get to know about that by two signals called as, one is ready signal and one is wait signal. So CPU can generate these instructions, or suppose CPU can generate these operations, initiate the memory read or initiate the memory write only when the ready signal will be enabled and wait signal will be disabled. So CPU will try to access the memory. First CPU will check if ready signal is enabled. Yes, then CPU will initiate all these operations that send the address, data or signal or something like this. So here is the concept of this ready and wait. Whenever wait signal is enabled, which means CPU cannot initiate any memory operation, CPU will have to wait. As soon as this ready signal is enabled, then of course CPU can initiate the operation using these three kind of buses. Okay, I guess Ashish, your answer is, your question is answered. Okay, fine. Now let me write. Let me write what happens in the memory read. What happens in the memory read operation? The very first thing is CPU sends address to memory using address bus, right? Using address bus. After that, CPU enables what? CPU enables the read signal. Okay, read control signal for memory. Then memory will understand, okay, I have got an address in the address bus. On that address, I'll have to go and read, perform the read operation. So third point is the memory performs read operation and sends the data to CPU using what? Using data bus. See, this particular thing is very simple if you understand, but still I have written so that you can remember for the longer time. Of course, your memory is not persisting memory, your actual memory. That's why I'm making this particular note so that you can remember for longer time. Memory write. What happens in the memory write? The first thing, CPU sends address to memory using address bus. Using address bus. Now next, second thing, what happens in the second point? After that, you remember in the write operation, CPU will only send the data. So CPU will send now, CPU sends data also to memory using which bus now? Data bus. And at the end, CPU sends enabled write signal to memory. Write signal to memory. Right now, what happens? Memory receives the write signal. Now, see, memory will perform the write operation. Hence, at the end, memory performs write operation on provided address. Whatever address is provided, on that address, this memory will perform the write operation. So these are the operations happening in the memory in this particular sequence. Okay. Fine. Okay, now let's have a simple question for you guys. Okay, I am not going to answer for this particular question. You only find out. If you find out, you can immediately type down the answer in the chat and you can send me the answer here. Okay, I am asking that in the read operation, data to goes from memory to CPU. Okay, imagine something. There is nothing over there. Just imagine in the memory read operation, the data goes from where to where? From memory to CPU. Then why read signal is going from CPU to memory? Why read signal is going from CPU towards the memory just because the data goes from memory to CPU? This is very common question. I think you might think that this is very stupid question or something, but this is the question so many times students have asked me, sir, data to goes from memory to CPU in the memory read operation, then why you are having the signal going from CPU to memory for read operation? You only think if you have answer just type down and send it here. If you don't have any answer, it's fine. So many people will be writing definitely and they'll be giving you the answer. People who have joined later, just like this particular video so that our video will be going viral. Not exactly viral, but it will go popular and more students can be benefited. What is the benefit you can get out of it is it will give us motivation to give you more and more free content without any fee. But if you are not paying any fee in terms of money, then you need to pay something to us so that it can give us more and more motivation for bringing you lots and lots content. And what you will pay us? You will pay us likes, subscribes and the shares. You share this particular video and the channel link to all of your friends and social media so that those people also who are not able to join any coaching class or Unacademy Plus, those people will be able to access these videos and those also will get benefited. Fine. Okay, so let's go further. Let's go further and let's try to understand this concept micro operation. I'm not going to give you this particular definition first. I'm not going to explain this. If you are concentrating on reading and it, then let me see here what is a micro operation. I guess all the registers are done. Yes, all the registers are done, so we can go here for the micro operation. Okay, there are so many answers. I am not having as of now the time to read all those things just because it will, distract me from my original video. So let's go and let's try to understand what is a micro operation. Okay, so here it is the concept. If my CPU wants to perform any operation, let's say execution of one instruction, only one instruction itself, or even you break it down to even one particular phase of instruction execution. If suppose you know all these, if suppose you all know this, that's good. If you don't know, it's fine. You just imagine one operation. If suppose you know all these, that instruction execution requires instruction fetch or operand fetch or execution or write back. Multiple things are required, right? Operand fetch or decode or something. So if you talk about even one phase also, like instruction fetch also as one operation. Okay, so you just imagine one operation. If CPU wants to perform, then CPU is not capable to perform one operation in one step. I'm not going into the technical details as of now that what is one step or what is that one operation or whatever. Just imagine CPU wants to perform one operation and that one operation CPU cannot perform in one single step. In one step CPU cannot perform. Then what CPU does? CPU performs the operation into multiple small steps. Multiple small steps. अब आपके दिमाग में एक क्वेश्चन आएगा, ऐसा क्यों? Why you will ask the question, why ऐसा क्यों? Just because I am not going to give you reason now. Keep that in your mind and I will uncover this particular suspense in the control unit, that why it happens. But till that time, you need to remember this, that my CPU can perform all the operations in small steps, and each of that step is known as micro operation. One smallest step which CPU can perform, or one particular smallest operation which CPU can perform in a single step, is known as one micro operation. Now I'm taking you a simple example from real life. This is, I guess, my first, or I don't know which one for you guys, but this is my teaching style, that I will connect most typical topics or complex topics to the real life things, so that you can remember your topic for the longer time. So let's talk about this. Suppose from your college or your school or from your office you are going back to home. Assume that it's a regular day and you can go out. There is no any corona or lockdown problem. Okay, so you are going out, coming back from your college or office, and your best friend also comes to the home along with you. So you both are sitting in into your living room on the couch, and then you got to know that your father has come from office or business trip or from outside, and he has brought lots of sweets for you, lots of those things which you like, sweet or whatever you like most. What you will do, you will rush towards the refrigerator, you will open the refrigerator, you know what are the things before you left home in the refrigerator. Why? Just because for unnecessarily you used to open the refrigerator multiple times. It happens. ओपन किया, कुछ नहीं मिला, वापस बंद कर दिया, फिर ओपन किया 15 मिनट बाद, कुछ नहीं मिला, वापस बंद कर दिया. अरे ऑटोमेटिकली चॉकलेट नहीं आ जाएगा वहां पे. But that's the normal human tendency. Every person does that. Fine. So what happens? You are going towards, rushing towards the refrigerator, opening it. You are seeing that, you're watching that. Okay, this is the new box. Taking the sweets, taking the dish, and you are eating. So this is the operation. Operation is from the couch and eating the sweet. This is one complete operation. Now this one complete operation, if your CPU will perform, then what happens? If your CPU will perform, what happens? This happens. Okay, so let me explain you what. Suppose your friend is not aware about the new dish, or suppose your refrigerator or something, right? So you are coming back to your couch and your mother from the other room is shouting that usko bhi khane ko de, right? So what she'll say, just give him also or her also something to eat. Then what you will do? Hey, jana re, tu leke aa. You go and take it. So that fellow will say, what, kahan se leke aau, from where I should take? Now you are performing micro operation with him. Means that fellow will perform small or micro operations to get that particular sweet. You will say, okay, go to that room, one micro operation. In that room, turn right, one micro operation. In that left corner you see refrigerator, another micro operation. He says yes. Then open the fridge door, second door from the top. If suppose you have multi-door fridge, second door open. Okay, from the bottom, fourth compartment, take the green color box and then eat it. So these are the small operations which your friend is doing on your command, so that that friend can fetch the sweets. Right? Now listen, one step I am telling you. In one step my CPU can perform one micro operation, right? Okay, done. Other than that, on what command, on what, whose command my CPU will perform the operation? So who will generate the command? The commands will be generated by your control unit. So control unit will generate the command, and rest of the system will perform the operation based on those commands. So whenever one type of command is generated by your control unit, one particular small operation is performed, and that small operation is micro operation. The technical detail, that how control unit generates the command and how micro operation is performed, that I will teach you in data path. Yes, a very beautiful concept it is. If you want to learn it even before I explain here, then you can fetch a control unit first. First special class of control unit in Unacademy, that is already recorded. Left it there. I have left it there, recorded freely. So you can fetch special classes under my profile on control unit, and you can get to know that how exactly this microprocessor is micro operation is being performed by control unit. Today, you need to remember what? CPU cannot perform one operation in one step. So CPU will have to perform all the operation in small step. And each step CPU performs in one step, one operation is performed. CPU step is called as micro operation. Okay, fine. So micro operation, did you get the basic idea of micro operation? Now the technical definition says what? If CPU is performing some operation, from where CPU will get those values to perform the operation? On what values CPU will perform that operation? Those values which are stored in the CPU's register, of course. So here is the definition, technical definition: the operations executed on the values stored in the registers, those are known as micro operations. Okay, but you remember what is micro operation? The smallest operation, smallest step which CPU performs. Okay, so if I'm saying, I'm just asking you that I want to copy the content of program counter into address register. This is one of my requirement. So this is one of my micro operation which my CPU wants to perform. See, if I want to have CPU to be perform this operation, fine. How will I understand this? If I want to say somebody that this operation right now CPU is performing, copy the content of program counter into address register. Now see, there are so many such kind of micro operations which CPU can perform. To denote all those micro operations, if I write like this long statement, it will be very lengthy also to read and it is not too handy. Okay, so scientists have given a notation language. What scientists have given? See, scientists have given a notational language and which is called as register transfer language, RTL. And in that register transfer language, to denote the micro operation is easier, understanding is easy. How you will understand this particular operation? Address register will have the content of program counter. You can write it down like this. So program counter's content goes into address register. Is this better or this one is better? First one is better or second one better? Which one? This one or this one? Of course, this is better to understand. Why? Just because it is more clear. With this also, with less number of characters, you can denote and understandable also. I don't have to read entire content. So here symbolic notation to describe the micro operation known as RTL, and this RTL is never executed anywhere. Okay, it's just the symbolic language, it's just the symbolic notation language. Okay, there is no any execution or something. पता चले आप बोलते हो सर इसका compiler कहाँ मिलेगा? इसका compiler नहीं होता कुछ भी. There is no any assembler or compiler for this. You can't execute it yeah, on CPU. It's just the notations. Okay, so let's try to understand this, that micro operations can be what type. Basically these three micro operations today we are going to cover. Okay, so if you want to denote micro operation in the RTL, how you are going to write? So if you are going to write register transfer, just now only I explained you this way, or some of the notations say like this way. The meaning is same to same, that register R2's content I am copying in R1. Ab arrow this way you write or this way you write, both are same to same. It's just the notation. There is no any standard. A basic standard that notation, you can use this notation also. You can use this notation also. Next, comma. If you are writing two micro operations like this way, R1 is equal to R2 plus R3, comma, PC is equal to PC plus 1. If you have written two micro operations separated by comma, it means both micro operations can be performed simultaneously. So there are certain chances, some chances that CPU can perform two micro operations simultaneously. If there are some chances like this, then you can write those two micro operations in single line separated by comma. Now you will have a question. Yes, definitely question should arise. अगर नहीं है तो मैं बताता हूँ कि question क्या आना चाहिए, कि when it can be possible. When it can be possible that CPU can perform two micro operations in a single step. That again I am telling you, keep that in your suspense list, and that I will reveal in the control unit chapter. Okay, so next one is memory transfer. What memory transfer is? Memory transfer means memory read or write. So let's try to understand these two things one by one. First, I am trying to say how you will denote memory read operation. You only tell me in the memory read operation, the data will come from where to where. The data is transferred from where to where. Data is transferred from memory to CPU. Right or wrong? Yes, correct. So in the memory read, data is transferred from memory towards CPU. Now we will have to be very specific. Yeah, पूरी memory का content पूरे CPU में जाएगा ऐसा थोड़ी है. Entire memory's content you are fetching and you are copying into CPU. Not at all. Memory is 4 GB, 8 GB, 12 GB. इतना पूरा content you cannot keep into the CPU. Full content you cannot keep in the CPU. So you are bringing only a specific content from memory. And how you specify that? By specifying the address. By specifying the address. So how you actually write this CPU to memory transfer? You write like this. Capital M, which denotes the memory access. In the square bracket, you write the address from where you are fetching the memory content. So wherever you are performing the read or write, that address you need to mention here and arrow, and this particular side instead of CPU where I should write it in some kind of register R1, R2 or whatever. So like this, you will have to write an RTL statement for memory transfer, memory read. Now there are actually two options to actually denote this address. There are two options through which you can denote this address. Okay, so what you can do is you can write like this way M, and directly you are giving the address something like this 2000. So you can denote this address or you can specify this address by two ways. One is directly you specify the address 2000, 3000, 1000 or something in any kind of number system. Suppose you are using decimal or hexadecimal or something. Based on that, you can specify that address value directly here, or you can specify some register here which is holding the address. Suppose AR register is holding the address, then you can write like this. I am again repeating what is the meaning of this statement. What is the meaning of this statement? AR register is holding one address. AR register is holding one address. That address you need to use to read the memory. That address you need to use to read the memory. So if in the AR suppose 1000 is there, in AR suppose 1000 is there, which means R1 is equal to memory and on address 1000. Very simple. Similarly, now this particular thing too, you will have to only tell me. I am not going to tell you how it is happening. Memory write operation. Memory write operation. How to perform memory write operation? From where to where data goes in the memory write operation? From CPU to memory. From CPU to memory, the data is transferred, right? So how will I write it? From CPU means some register, let's say R1. Data going towards memory, yes, data going towards memory, and in the memory where I'll have to specify the address. Now you will have the same kind of concept again. Here also you are having same two options you are having to specify the address, same this way or this way. I guess now I if I leave this particular thing here only, then also you can remember this. So instead of address, you can copy directly address value, or in fact you can keep some register also here. Fine. If you are fine with this, then I guess this is the time to wrap up today's session. Okay, but before that, I want to tell you tomorrow we are going to learn different types of micro operations I had here in my list. So these micro operations we are going to learn with detail, that how shift happens, rotations, arithmetic shifts and all, and based on that we are going to solve some of the questions which are some previous date questions and some normal questions. Fine. So if you are following me here and if you are liking this particular lecture, if you want to learn more about this particular course, more topics you want to read, then you can follow this link VD_Boti on the Unacademy profile. So you just search my name on Unacademy, Vishvadeep, and then my profile will be visible. Go to my profile, follow over there so that you can get all those already recorded classes plus more future special classes. So there are some special classes, if you are not aware about, then those special classes are free classes. Yes, free classes in Unacademy platform also. So you can access those free classes which are pre-recorded, and two subjects I am teaching there. One is computer organization, one is data structure. So both the classes or both the courses classes are already available there. You can fetch those classes from there and you can learn more things. Plus I am having some upcoming classes also. About those also you can get notification if you will follow me over there. Fine. So few more things are like this. One is on the Unacademy Plus, I have started a course, computer organization, which is a comprehensive course, and that is going into the full-fledged details. Right, it started on 13th July, so you are not so late to join Plus. If you want to join Plus, remember this is the code VDeep10 is my code. Anytime you are going to get the subscription, use this, and then you can get my special mentorship about your preparation and every single thing. Fine. So these are my contact details: Facebook, Instagram, and Telegram. You can send me personal messages on Telegram or on any social media if you want to know more about subscription or any other preparation details. Send me messages and mention that you are learning this course, whichever course, from whichever the medium, so that I can know what exactly your requirement is. Fine. So happy learning, enjoy, and join the Unacademy. Follow my profile over there. Okay, till then, another thing, Malaysian Sir's class on the same channel is going to start at 8:30 p.m. so you can learn TOC from him. Okay, so join that class live on YouTube, same channel. Till then, enjoy.